Okay, good evening, everyone. So we are here to review the Seng Kang Sec paper. Now, as usual, we will start from paper 3, the structured questions. Now, for question number 1 is a one-word answer, choosing from the helping words, the list of helping words. Now, importantly, you need to realize this instruction. When they give you helping words, usually every word can be used once, more than once, or not at all. So it's not a case whereby you start crossing out the helping words when you have used them once. All right, please note that you can use them more than once. Okay, I'm going to give you the answers very, very quickly. Okay, please cross out point C. Part C, there's no answer for this. Okay, so it's a wrong question. Okay, so please check your answers for A, B, D, E, and F. So cross out part C as there's no answer for part C. All right. Now, importantly, I would like to draw your attention to B. I hope you know by now, group 1 metals. Group 1 metals will be soft and have a relatively low melting point. So for example, the melting point of potassium, which is from group 1, is actually only 63 degrees Celsius. So potassium melts at 63 degrees Celsius. So it tells you that potassium has a low melting point. All right. Now next, for part D, what is a component of brass? Brass contains copper mixed with zinc. And therefore, copper or zinc could be the answer for part D. And finally, part E, what reacts with steam but not cold water? So you're going to remember the reactivity series for this. So if you recall the reactivity series, this is the reactivity series. Only the first 4 reacts with cold water. Okay, so only potassium, sodium, calcium, magnesium can react with cold water. Everything else will not react with cold water. All right, so I'll just give you everything else in the list. All right, so only the top 4 metals can react with cold water. Therefore, the answer is zinc. Zinc doesn't react with cold water, but zinc reacts with steam. When zinc reacts with steam, it forms zinc oxide. All right, so if you have forgotten the equation, this is the equation. Zinc, which is Zn, plus H2O, gas, because it's steam. Steam means gas. It forms zinc oxide, which is solid. Hydrogen gas, which is, of course, G, gas. Okay? Now, for part C, there's no answer because silver doesn't react with acid. Silver is below hydrogen, so it doesn't react with any acids at all. So there's nothing formed if silver would be placed into acid. And therefore, part C, just cross it out. There's no answer for that. Now, moving on to question 2. Now, question 2 is a question that requires reading, significant reading. Okay? Now, whenever you are given a text to read, you must ensure you read every single part of it. They have tried to help you by breaking it down to bullet points. Please read every point. Now, importantly, please highlight the chemical names. So you are extracting pigments. Pigments are colored substances from the leaf, in this case. So you have to crush the leaves, soak in ethanol, filter the leaves, right? And then you concentrate the extract and run chromatography using propanone as a solvent. So the solvent for chromatography is supposed to be propanone. So now you look at the setup which the student has done. Immediately, the first error is obvious. The student has used water. Usually for chromatography, we use water as the solvent. However, you have been told the student is supposed to run the chromatography experiment using propanone. So the first error is that The students should have used propanone as a solvent. Instead of water. All right. So the idea is the solvent is supposed to be propanone, probably because the pigments are not very soluble in water. Using propanone probably would have made the separation better. All right. Now, the next error, which is actually shown in the diagram, is this. The water level is this high. However, the start line is this low. So now imagine you have used so much water that it submerges the start line, right? So when the water level is this high, your dyes, your pigments will just dissolve directly into the water without even moving up. So the idea is the water level, the solvent level cannot be so high. It needs to be lower. So the solvent level should be below the start line. Whenever you use the solvent for chromatography, add as little as possible, such that it does not submerge the start line. It should be below the start line. Why is that so? It should be below the start line such that the pigments do not dissolve directly into the solvent without moving up. The whole purpose of chromatography is for the pigments to move up. If they dissolve directly into the solvent and don't move up, it defeats the purpose of the chromatography. All right. Now, please suggest how the student could correct the errors. So when writing the errors, you should use such a phrasing. The student should have done blah, blah, blah. The student should have used blah, blah, blah. Always say the correct case first. The student should have done blah, blah, blah. This will tackle the question, suggest how he could correct them. So you need to state what is correct. In this case, he should have used propanone. The solvent level should have been below the start line. This is what's correct, okay, which the student didn't do. All right, so that's 2A. A little bit unusual, okay, compared to your usual practicals or your usual papers. All right, but nonetheless, it's very much in the syllabus. Okay. Now, some of you also stated about the hanger, for example. The hanger is correct. All right, the hanger just allows it to hang on to the lid. Okay, moving on to 2B. So in 2B now, you are given the pattern and the results are shown. Okay, mine is a bit cut off. Now, I really wanted to go through 2B part 2 and 2B part 3. On your papers, you can see that red cabbage is not sure whether it contains xanthophyll or chlorophyll. And I think many of you have been asking me this question. How do you explain that you can't tell? I think you know the concept, but you may not know how to explain. So here's how to explain. I'm sure you realize the red cabbage contains a long streak. So the very long spot is called a long streak. And because it's so long, it could correspond to xanthophyll or chlorophyll, right? Because it's so long, you can't really tell which spot is it. Does it correspond to the spot at the height for xanthophyll, or does it correspond to the spot for chlorophyll? Why cannot tell? Because as these two pigments have similar heights. Right? Xanthophyll and chlorophyll are relatively similar in their height from the start line. And linked to chromatography, what determines the height of the spot? The distance or the height is determined by the solubility. So if they have similar heights, they have traveled similar distances, they have similar solubilities in the solvent. So that's the idea. Whenever you have a long streak, it is because you have two different spots, two different substances with similar heights. The similar height is due to similar solubilities. So please learn this. Whenever you see an elongated spot in chromatography, this is the reason. Because you may have two or more different spots which have merged together. They have merged together because they have similar heights and solubilities. That's the principle behind chromatography. And once you understood this principle for B part 2, you can easily suggest the answer for B part 3. So how can you suggest better separation? So when we mean by better results, what we mean by better results in this case is really better separation. How do you separate the xanthophyll and chlorophyll better? Since you know it's about solubility, obviously, to change the solubility allows you to separate them better. But how do you change solubility? You will need to repeat the experiment with a different solvent. So this is always the idea. To separate a long streak out, always change the solvent. Redo the experiment for chromatography using a different solvent. Because if I use a different solvent, the solubility will change. Solubility is dependent on the solvent itself, whether you use water, ethanol, or propanol. Okay? So now let's move on to question 3. Now for question 3, it's really just a matter of filling in correctly. So I think the first one shouldn't be too difficult. The first row is doable. It's the second row that you must be careful. For the O levels, in the same table, you could be given atoms and ions. So you need to know what is oxide ion. The oxide ion means it has already gained electrons. So if you think about oxygen, oxygen is in group 16. Group 16 has 6 valence electrons. Therefore, it will gain 2 valence electrons. So it forms O2 minus. So it still has 8 protons, but now it has gained 2 electrons. Therefore, it's 10 electrons. All right, so please be careful when counting the electrons. Pay attention. Is it an atom or is it an ion? Okay. Then we go to 3B. Now, 3B is another part that I will start. Now, this has actually come out for the O levels before. It's modeled after one of the TYS questions. So you are asked to state 2 ways in which oxygen molecules behave differently when oxygen is above the boiling point, below its melting point. So first things first, oxygen molecules is O2, is a diatomic molecule. Secondly, above boiling point means what? So if you think about it, there's a melting point, there's a boiling point. Solid, liquid, gas. So above the boiling point means this way, above BP. If it's above BP, that means the state symbol, the state, is gaseous. Conversely, below the MP, below the MP should be solid. So you are basically asked, how does oxygen differ depending on whether it's a gas or whether it's a solid? You are given 2 differences. What can the 2 differences be? So if you think about the chapters that you have learned, this is under chapter 3, but specifically it's under the chapter of kinetic particle theory. In kinetic particle theory, you are basically focusing on the arrangement of the particles and the movement of the particles. And therein lies the two differences. One has to do with arrangement, the other one has to do with movement. So once you have understood that, you just need to write it out. So the arrangement of oxygen molecules above its boiling point is spaced far apart in an irregular or random manner. But below its melting point, it is closely packed in a regular manner. All right, so it's about comparing the gas versus the solid. All right, spaced far apart, irregular, that's a gas. Closely packed, regular, solid. Next, so from arrangement, we now move on to movement. So you got to recall what is the movement type in a gas. So the movement of oxygen molecules above its BP is moving in all directions at high speeds. So above the boiling point is a gas. So the particles, the molecules in this case, in a gas should be moving in all directions at high speeds. While the molecules will be vibrating about fixed positions below its melting point. So below its melting point is a solid, therefore it will only be vibrating about fixed positions. Okay, so Mr. So over here, we have mentioned the gas first, then the solid. Could you do solid first, then gas? You could. All right. So now we move on to question 4. Now, question 4 gives you details of 4 different particles, M, N, P, and Q. All right. So you're given a nucleon number, the proton number, and the electrons. All right. Now, for question 4, the way to do it correctly is always look at the proton number first. By looking at a proton number, you can determine the element's name. For instance, 12 protons. You just need to go to the periodic table and look which element is proton number 12. And you will come to the conclusion it's magnesium, Mg. Which element is proton number 9? It's fluorine. Similarly, fluorine. 8 is oxygen. So the idea is using the proton number, we should immediately work out what the element is. The next thing we look at is the electrons. After the protons, we look at electrons. Why? Because if the electrons and the protons are the same number, it's an atom. So M is a magnesium atom. N is a fluorine atom. However, once you come to P, immediately you observe that, hey, it has 10 electrons, not 9. It has 1 more electron than proton. Electrons are negatively charged. So this is the F- ion. Finally, the last one is also an atom. And with that, you are totally able to do everything here quickly. Okay? Now, for isotopes, I know we have mentioned that isotopes should be atoms of the same element. In this case, hey, one is an atom, one is an ion. But you can clearly see that there are different number of neutrons. So N and P have different number of neutrons. So they have originated from different isotopes in the first place. Okay, so N and P is the best answer for part 4. Okay, next you're asked to draw the dot and cross diagram of the compound formed between particles M and N. All right, so you got to ask yourself, magnesium, fluorine, if they react together, what's the formula of the compound? MgF2, right? So in this case, Mg, of course, is particle M, F is particle F. Okay, so now let's start. So at first, magnesium is 282. It lost the 2 valence electrons, so now it's 28. But we only show the outermost shell. So it's Mg2 plus. Fluorine is 27. But it gained 1. When you gain 1, that electron gained must be drawn with a different symbol, as you can see using the dot over there. F minus. But the formula is MgF2 because it's Mg2 plus F minus. Therefore, to balance out the plus and minus, I will need 2F minus. That's why the formula is MgF2. So this is the dot and cross diagram for the particle, the compound form between particles M and N. Generally speaking, you can draw it like that because you know it's MgF2. However, it's more common to leave it as M and N. So if you have written Mg and F, that's also fine, but it's more common to leave it as M and N. Okay? Now, generally speaking, I will write MgF2, but the final answer, I'll write M and N to link back to the question, right? So that's it for question number 4. Okay, moving on to question 5, which is rather short. This whole question is about redox, more or less, right? Now, you're asked to identify the reducing agent in this reaction in 5A. Now, it might be easier to answer 5B first before answering 5A. Because once you answer 5B, you probably can work out what's the reducing agent. Now, 5B is a particularly common redox question. You're always asked to explain in terms of oxidation states why something is reduced or oxidized. And in this case, why this is a redox reaction. So how do you explain? Please look at the format of my explanation. Please write F2 is reduced as the oxidation state of fluorine decreases. You have to say that the oxidation state of fluorine decreases. If you have wrote something like as its oxidation state decreases, it's wrong. It's not its oxidation state. It's oxidation state of fluorine. The element's name is fluorine. Next, if you have written the oxidation state of fluorine changed, it's wrong. They are looking for the word decrease. So you cannot say change. It will be marked incorrect. Now it decreased from, over here on the left, it's an element. F2 is an element because it's not combined with something else. Therefore, the oxidation state is 0. But on the right-hand side, this is -1. I know this is -1 because hydrogen is +1. Okay, so HF, hydrogen's oxidation state is +1 because hydrogen is usually +1 in a compound. So to balance out the +1, fluorine must be -1. So it went from 0 in F2 to -1 in HF. If you just wrote from 0 to -1, it's wrong. It's from 0 in F2 to -1 in HF. So this is the expected answer for redox. Okay? If you have written something else, it's incorrect. Okay? The only sentence that's accepted is this sentence, this format. Okay, so if your wording has changed from this, that means it's incorrect. So conversely, hydrogen H2 is oxidized. Notice how I always write the formula. I don't write hydrogen, but I write H2 because the substance that's reacting is the diatomic H2. If you wrote hydrogen, I'm not sure if you are referring to hydrogen in HF or are you referring to hydrogen in H2. So be specific. The one that's oxidized is the one on the left, H2. So just write the formula down. H2 is oxidized as the oxidation state of hydrogen increases from 0 in H2 to +1 in HF. Okay? So your redox must look like that now. Whenever you write redox explanations for oxidation state, it has to be in this format. So how do you explain redox? Since this reaction involves reduction and oxidation, this reaction is redox. So if you didn't have the sentence in blue, your answer is not very complete. So please add it in. So we are doing 5B first because 5B allows us to work out which substance is reduced, which substance is oxidized. And with that, I'm sure you can work out the reducing agent to answer 5A. So reducing agents are themselves oxidized. So recall that reducing agents are the ones which are themselves oxidized. So just look what's oxidized. The substance which is oxidized is the reducing agent. Therefore, H2 is the reducing agent. All right. So that settles 5A, 5B, which are the redox portions of this question. Okay. So this reaction is about hydrogen gas reacting with fluorine gas to produce hydrogen fluoride gas. So H2 plus F2 becomes 2HF. Okay. So now this is a redox reaction. But now that we have the HF gas, you are told HF dissolves in water to form an acidic solution in 5C. Suggest the test and the observation to determine the nature of the solution. I think some of you were confused by this word, nature. What does nature mean? The nature of the solution refers to whether it's acidic, neutral, or alkaline. So nature means acidic, basic, neutral, amphoteric. In this case, it's acidic. You are told it's acidic. So how do you prove that it's acidic? That's all they are asking you for. So of course, the simplest test would be you could just simply place a piece of moist blue litmus paper into the solution, right? As HF is acidic, as you are told, the moist blue litmus paper turns red. So nothing very complicated, just suggest the simplest test to prove something is acidic. Okay? Now, of course, besides litmus paper, you could have used universal indicator. So if you add universal indicator in, you would expect the color to be either red, orange, or yellow, of course, depending on the pH of the acid. Okay? Now, generally, when we use litmus paper, I would strongly recommend that you write the word moist or damp. Of course, in this case, the solution has water on its own, right? It's aqueous solution. But nonetheless, just write a moist blue litmus paper. I think it might be simpler for you to remember. Okay. So now moving on to question 6. I think for question 6, identifying the two gases, C and D, should be straightforward. So C is really carbon dioxide because it forms a white PPT when it's bubbled into lime water. D is ammonia gas because ammonia is an alkaline gas that will turn moist red litmus paper blue. Finally, E is the white precipitate when silver nitrate is added. Therefore, E must be silver chloride. Now, this part is okay, but let's work backwards to find out what A and B could be. So if you think about it, A and B is a mixture of A and B, right? The mixture of A and B can produce ammonia gas, carbon dioxide. This tells you that clearly it must be ammonium compounds. One of them is ammonium carbonate because it's the carbonate that gives you CO2 gas. It's the ammonium ion that gives you ammonia gas. Now, you are told further that A and B are made of the same cation. Cation means the positive ion. So the ammonium ion is the one that is the same. The only difference is the anion. And you have deduced it must be the chloride because when you added silver nitrate, it formed the white PPT of silver chloride. This means that A and B contained chloride as well. So the two compounds are ammonium carbonate, ammonium chloride. You could have swapped the order around. That means you could have said ammonium chloride as A, ammonium carbonate as B. It's fine because it's a mixture of A and B. We don't have enough information to tell which is A and which is B. All right. So A could be ammonium chloride, B could be ammonium carbonate as well. But I'm more interested in part C. Suggest why effervescence is observed when acidified barium nitrate is added to the mixture of A and B. Now, this question is not difficult. The moment I write the answer out, you would immediately think, oh my gosh, why didn't I think about it? The problem with most students is that they will focus on the barium nitrate and wonder, how can there be a gas from barium nitrate? If you think about it, barium nitrate is a test for sulfate. Right? So barium nitrate is a test for sulfate. The test for sulfate produces white precipitate. It will never produce effervescence. So the barium nitrate is not the key. The key is the acid that you had to add. It's acidified barium nitrate. So it's the acid that matters here. Why? A and B is over here in part B. You can see that. A and B is over there. Which one might react with acid? Just circle. Make it visual and visible for yourself. The one that reacts with acid is not chloride. There's no reaction, acid plus chloride. You've never learned that. Ammonium doesn't react with acid. There's no such reaction. Acid plus ammonium, no reaction. However, you have learned acid plus carbonate. And therefore, the acid in acidified barium nitrate reacts with the carbonate in A and B, the mixture of A and B. And this forms CO2 gas, right? Acid plus carbonate forms carbon dioxide gas, which is observed as effervescence. So you have to mention it's the acid that reacts with the carbonate. It's 1 mark. And this produces the gas called carbon dioxide. And therefore, you observe effervescence. Okay? So that is the trick to question number 6, part C. Which is not that difficult. All you needed to do was to highlight and think which is the part that gives you a gas. Of course, you need to realize that effervescence means gas produced. If there's no gas produced, there is no effervescence. All right? So effervescence means there must be a gas produced. In this case, got to think, barium nitrate won't form a gas. So it is the acid that reacts with the carbonate in A and B that gives you CO2 gas. Now, the main reason why we are doing this paper is really because of question 7. Question 7 is the experiment planning question. For the pure chem students, the experimental planning question is in their practical. However, for the combined science, the experimental planning happens to be the theory paper, paper 3. Okay? It's usually 4 to 5 marks. So you need to be able to plan experiments. Now, how do you do this such a question, right? The idea is the same. Always highlight the key terms. You have to highlight the words, like chemical names. All right? So you have 2 different acids here, hydrochloric acid and ethanoic acid. The next thing you pay attention to is the definitions. Are there any new terms introduced to you in the passage? You are introduced to this term, strong acid. So hydrochloric acid is a strong acid, which means that it dissociates fully in water to produce a high concentration of H+ ions, meaning hydrochloric acid has a high concentration of H+. On the other hand, ethanoic acid is a weak acid, which dissociates partially, and this produces a low concentration of H+. So now you realize the idea is both acids, while they can have the same concentration, they don't have the same concentration of H+, because ethanoic acid is weak. If ethanoic acid is weak, and this is ethanoic acid, it dissociates reversibly and partially. All right, so you might want to take this down. Notice the arrow that I've drawn is a reversible double-headed arrow. It's a double-headed arrow, which indicates to you that, okay, it doesn't dissociate fully to form H+. Okay, so the difference between HCl and ethanoic acid is the concentration of H+ that it produces. Now, after you have highlighted the words, names, definitions, you should always highlight the pattern. Patterns and relationships are always phrased like that. The more something something, the something something. This tells you it's a pattern or a trend. The trend or the pattern here is the more readily an acid dissociates, the faster the speed of reaction. You need to realize this because speed of reaction is the key word here. Okay. If you didn't realize this, it's going to be difficult to do the problems later on because you wouldn't know what experiment to plan. If you have read the first paragraph, you would now know that, oh my gosh, I need to plan something related to speed of reaction, right? If not, what's the point of telling me speed of reaction in the question? So, before we go on to read, which one has a faster speed? Is it going to be hydrochloric acid or is it going to be ethanoic acid? So now let's think. Before we move on, which one is faster speed of reaction, HCl or the ethanoic acid? So you just based on concentration alone, I think you can work that out, right? Concentration higher, speed of reaction is faster, meaning HCl has faster speed of reaction. Now let's write this down at the side. This is all your thinking process, which you have to write down in an exam. Not everything that you write is just for marks. You need to try to write out your thinking processes so that when you finally plan the experiment, it's coherent. If there is no such annotation of the question, that means you are not thinking through and analyzing the question. If you look at your paper now, if your question is still so clean, there's no annotation, no underlining, no circling, no nothing, that means you're not analyzing. If you're not analyzing, then you're not trying your best to put in a very detailed answer. So many of you, you will realize that actually what you are lacking is the annotation of the longer questions like this. Okay? So everything that I've written right now is everything that I expect my students to be writing. Okay? Now, once you have deduced that HCl reacts faster, you are ready to move on to plan. Because now you are told you are given HCl and ethanoic acid of the same concentration. But we know same concentration of the acid doesn't mean same concentration of H+. HCl has a higher concentration of H+, right? So now you are supposed to carry out an experiment to show that HCl is a strong acid, while ethanoic is a weak acid. This one you must pay attention to it, because you're going to come back to this later on in your experiment. This is what you're supposed to show. Your experiment must show it. For combined science, they have tried to help you by asking you to choose and describe a suitable reaction. This is number one. You need to describe chemicals to use, measurements to make. You need to include in your description a variable to be controlled. So in total, you have 4 different things to do. Now, I'm not saying that you must answer 1, 2, 3, 4 in sequence. You don't have to. You don't have to answer them in sequence. But your experimental plan should have 4 things in there. And these are the 4 things. And that's why this question is 4 marks. Okay? So in the question itself, you need to take note what needs to be answered. Number them 1, 2, 3, 4. All right? And now we are ready to start. If you have studied the speed of reaction notes, which are written by me, all right, you notice there's a very sizable section of the speed of reaction notes on planning experiments. There's a good reason for that, because I know that the combined science has many planning questions which are based on speed of reaction. That's why in your speed of reaction notes, I've deliberately put those questions in. Okay? So if you are still unsure about how to plan speed of reaction, please refer to my notes for speed of reaction. All right? Now, but a good way to have speed of reaction experiments is always to do gas collection. That means you always choose a reaction that produces a gas. Choose reaction that produce gas. So now you think, these are acids. So which reactions will produce a gas with acids? Okay, there are many, right? So you could have chosen acid plus metal. That gives you hydrogen gas. You could have chosen acid plus carbonate. That gives you carbon dioxide gas. Okay, so these are 2 possibilities. So, Mr. So, for the purposes of this, I will choose acid plus metal. All right, I'll choose acid plus metals. How am I going to do it? I usually like to number my steps, so it follows like a recipe. So first things first, you will add, let's say, 3 grams of granulated zinc. So I'm choosing my metal here. I've chosen zinc. I know it reacts with acids. All right. Granulated just means it's grains. Okay. So something like that. Just adding zinc to HCl. All right. Next. So you got to think, okay, zinc plus HCl forms zinc chloride and hydrogen gas. So what do you want to measure? Right? It says here, you need to describe the chemicals to use. You have described that. How would you measure something here? You could measure the volume of hydrogen gas, right? So of course, you need to stopper the flask. immediately. Next, what do you measure? You can measure the volume of hydrogen gas produced. Now, the keyword here is volume, all right? You can only measure volume. You can't measure amount. Amount is moles. Volume is cm cubed. So you're always measuring volume of gas. How do you do that? Gas strange. Again, you're not going to measure the volume only. You're going to measure it at 30-second or 1 minute intervals. Okay? Now you have tackled number 1 and number 2. You have described the reaction, described chemicals, what measurements to make, right? But that's not it. Of course, you have to repeat the experiment using same mass of granulated zinc and ethanoic acid of 1 mole per dm cube concentration. So what's the purpose of writing this line? Of course, you must repeat it with ethanoic acid. But if you noticed, I was very deliberate to show this. This. And finally, I forgot, at room temperature. This. These are the variables to be controlled. Okay, so just by writing this line out, I have stated what are the variables to be controlled. There is no need for a separate sentence. The variables to be controlled are blah, blah, blah. No need. In your description, if you have made it clear that this is the same, that means it's being controlled. Next, the last part is where you need to really show how does your experiment prove your conclusion that HCl is stronger. To prove that, we need to plot a graph. Plot a graph of volume of hydrogen gas produced against time for both acids. Okay. HCl will have the steepest, or steeper in this case only 2, right? The steeper initial gradient, as it has higher H plus concentration. That means it's a strong acid. Okay, so you need the very last 2 lines. You cannot just plan the experiment, that's it. You have to tell the experimenter or the audience what to do with the data so that you can prove that HCl is a strong acid. Remember, your objective is to prove that HCl is strong, ethanoic acid is weak. So you must do that. All right. So this is what will make a very good answer for planning speed of reaction questions. Okay, it's all about breaking down the question, knowing what you're supposed to measure, writing down exact quantities, suggested quantities of the chemicals you'll use, showing clearly what are the control variables, and finally, how to make use of the data, like I've written in points number 4 and 5. Okay,